We are at Flutter Hero, so from now on, let's focus on developer techniques.
We'll start with the basics. Actually, we won't spend really time on that. Obviously, the basics for optimizing the footprint on the device is to optimize the performance. So we'll have a look at the CPU usage, the frames per second. We can try to limit the usage of consuming hardware, like the sensors. We can try to work on the network, having a good cache strategy. You know these techniques. Those are the best practices. They are really well documented, so we won't spend time on that. Let's move on to the dark modes, because it's not always obvious. Welcome to this session about optimizing and reducing the carbon footprint in our applications. We will review many techniques, many developer techniques every Flutter developer can learn and can use. There are some of them we know you know, and probably others you may not. Anyway, it's really great to be at Flutter Heroes again with the community, thanks to the organizing team. And it's really great to see we have other inspiring talk today about accessibility and security. That is to say, we have many ways to make our applications better. And we think one of them is to mind about the footprint, to care about the impact of our application over the device, over our users, and the environment.
Yes, so quick presentation. My name is Alexander, but today you can call me Alessandro if you want, right? I'm with my colleagues, Alexis and François, and last year we spoke about our app, SNCF Connect, which is used by millions of users in France to access sustainable mobilities.
But we're not here to talk about our app. So today we will talk about, firstly, the product and design, then developer techniques, and then we'll finish with testing and monitoring.
And I propose we start with the why. Why are we here? Because we tend to think that our digital services, our applications, they are clean, it's free, it's only code, it's digital, you know. But that's wrong. In fact, the digital economy, it relies on real infrastructure, energy, materials, some of them being in very limited quantities on the planet. So according to l'ADEME, which is the French Agency for Ecological Transition, the digital industry is responsible for more than 2% of the world carbon footprint on the planet. And it's 4% of the greenhouse gas emissions. If we look at the latest report, we can see that most of the footprint comes from the device, the user device. It's not the data centers, it's not the network, it's the device. And most of the pollution comes from the production of the device. And the worst being our smartphones, because in all the devices, the smartphones really require many materials to be produced, and their lifetime is only 2.5 years in average, at least in France. So I think I've got an example. I've got mine. My own smartphone is an old one. It has 4.5 years. Can you believe it? I don't want to change it, but really, it feels like pain. It's so slow. Most of the applications are really slow now when I don't have to reboot my smartphone almost every day because of crashes. So maybe you've experienced something like that. We know why we change our smartphones. And really, I'd like to have a little interaction with you if you agree. I'd like to feel less alone. Maybe there's someone in the audience with an old smartphone like me. If someone has a smartphone older than 4 years, can you please clap your hands? Oh, really, we feel alone. Thank you so much. I feel less alone myself. Maybe we could hear the ones with a smartphone older than 2 years this time. Okay, 1 year, more than 1 year? And now, everyone, please. Okay, so we could hear something about this problem we have. We have to change our smartphone regularly. And Alexis, I think it won't improve. You have some other bad news.
No, François. Unfortunately, carbon footprint isn't our only concern. There's also the final energy consumption and also the resources used to its production, like water and metals. For instance, to give you a rough idea, one smartphone takes approximately 500 times its weight in rare metals and 90,000 liters of water to be produced.
And if we do nothing?
If we do nothing, the charts could go skyrocket by the middle of the century.
Okay, so that's the moment where you probably feel worried, sad. You may. Hopefully, we have solutions. We can do small things at our level. And before we move on to the developer techniques, we speak about optimizing our code. Let's have a word about the functional parts, our products.
Yes, thank you, Francois and Alexis, for this interesting introduction. So now we're going to talk about the product because, as we know, features matter and design matters. So how to build the right thing. And first, we can ask ourselves, where is the green part in our product, in our app? And that's a good question, right? And sometimes we think it will decrease the value of the product, and what's worse, increase the cost. But however, we think a compromise should exist, especially if we are concerned about accessibility and efficient design. So we should discuss it with our team, and then we'll probably find a good equilibrium and, of course, build a better product. So finally, maybe the most important thing is that we will be more engaged with final users and more compliant with the environment.
So the product matters, the product we build, not only how we build it. And I've got an idea. I've got this example, a good example. I know most of you know this application, right? Can you raise your hand, please? I guess, not many of you. So please have a look at the amazing video published recently on Google Play. It's the We Spot Turtles application. It's an application written in Flutter by Nicolas Guillot, and it helps collecting data and protecting sea turtles. So that's a really good example, in my view, of a valuable application, something valuable for the environment, for the community. Yet, not all of us are building applications to protect sea turtles. So what can we do when we're building something else and something, if possible, applicable to almost every application?
Yes, François, the next slide concerns the backward compatibility.
The backward compatibility, but that's a good thing, right? That's what doesn't force your users to change their smartphones. So it's a good thing, the backward compatibility, to maintain it. No, you mean there's a cost. There's also a cost at maintaining versions, backward compatibilities, modifying the payload for that, and that's it?
Yes, you're right. We know that it's a controversial subject, but we think that the key is just monitoring your app, observe user behaviors, and then when it's time, that means when users represent something not significant on specific versions, don't forget to clean up your payload, basically, or remote deprecated fields. And of course, don't hesitate to drop useless versions.
So backwards compatibility is a good thing, but it also has a cost. So that's a good example of something not trivial, something where there's a compromise you have to find on your services, finding the good balance and dropping what has become useless. Yes. And to conclude this part about the functional aspects, we are all used to the notion of technical debt. There's also a notion of functional debt on our products, the features we choose, the things we drop or we don't drop. And maybe the idea is that less is more, less useless features. We're not used to drop something which is not used anymore. We think it will decrease the value. If we have less useless, not used, unused versions, if we have less complexity in our implementation and less footprint, probably it's more because we improve the accessibility most of the time by simply simplifying things. We improve the user experience, and in the end, we probably improve the product value and even the business value. But let's stop with the functional part. We are not at a functional conference, right?
No, we're not at a functional work. We are at Flutter Hero, so from now on, let's focus on developer techniques.
So about the developer techniques, we'll start with the basics. Actually, we won't spend really time on that. Obviously, the basics for optimizing the footprint on the device, it's to optimize the performance. So we'll have a look at the CPU usage, the frames per second. We can try to limit the usage of consuming hardware, like the sensors. We can try to work on the network, having a good cache strategy, maybe provide an offline mode to our users, and optimize and double-check our assets. You know these techniques. Those are the best practices. They are really well documented, so we won't spend time on that. Let's move on to the dark modes, because it's not always obvious. You know, there are two types of screens, the LCDs, the OLED. So on a LCD, there's not much difference if you're displaying a color or another. But on an AMOLED screen, the screen is able to shut down part of the screen completely if the color displayed is black. So you save energy, you save the battery. And something we always wondered is, what about dark colors, but which are not plain black? And often we hear about, okay, it doesn't work. It's not plain black, it doesn't work. And that's not what we could measure with Green Spectre. It's a partner who is auditing our app regularly. And we could measure, even in our dark blue theme, a benefit in terms of battery, energy. And we've even calculated that at the end of the year, because we have millions of users, if all of our users using an OLED screen were in dark blue mode instead of the light theme, we would estimate it would save 7 tons of CO2 at the end of the year. Well, I don't know what it represents exactly, but there's a saving to look for. What we wanted you to remember about the dark modes is that it's not only plain black or nothing. Not everything is black and white. So don't hesitate to use the techniques of providing dark modes in your applications.
Threads matter too. A good thread strategy allows you to save battery life and also not overload the UI, so you end up having a better user experience. You have the main thread UI for simple tasks, but you also have computes or isolates. Compute is for Flutter and Dart is for Dart. Isolates I for Dart. For more complicated tasks like deserializing big payloads, parallel tasks, etc. And you also have Work Manager for more background tasks like a notification center. Yes.
Another technique, another thing important to keep in mind is to stay up to date. Simply that, to upgrade our libs, our tools, our frameworks. Because most of the time we'll get for free improvements, including improvements about performance and the footprint in the end. A very good example of this is Impeller and the recent improvements on shaders, on rendering. So we won't present that. It has been presented before. You know probably about Impeller. But really, it's a great example, and we could measure benefits in terms of performance with Impeller, clearly. It's improvements for free. Since we are at rendering, you have something?
Yes, it concerns the repaint boundaries. So you all know this technique in the audience because Greg already talked about it this morning, so don't lie. You all know this technique. So quickly, repaint boundaries permits you to split your widgets into subtrees. So that repaints subtrees doesn't need to repaint all the neighbors of the widget. So if we have huge animations or many widgets on your screen, that tool could help you in this case a lot. And we have a concrete example right below to share with you. With scrolling on our home screen, we can see that we have improved the CPU usage and repainting performance. So on the left picture, on the blue diagram, we have not used the repaint boundaries, and you can see the contrast with the second picture with repaint boundaries.
And now I think it's this moment which is always a bit awkward, where we are at a Flutter Developer Conference, and we'll tell you about some things about the server side. So don't worry, stay there, please. It won't be long.
It's not the dark side, so.
So another way to improve your footprint is by shifting some logic to the backend. So for instance, the back for front pattern allows you to put the presentation model, some mapping, formatting, localization, these kind of things on the server side. If you have multiple front ends or channels, it gives you more consistency as you have one to rule them all. You end up having less code, so less crashes. It's faster to redeploy as it is server side, and yeah, you also end up having a better time to market.
And we could measure a benefit and effect.
Yes.
Yes. Now let's have a look on some results. So using GreenSpectre, we could measure the benefit of this architecture. And we can see that we have less data exchange with payload on the networks compared to our previous app in yellow and the new app, which is SNCF Connect in black. And as Alexis said, why the payload is less big? Because the BFF pattern gives only what it needs to your apps. So it's already prepared for your presentation.
And we'll give you another example of something you can move out of the front end. I think that's something you really like to implement yourself. It's all about business tracking, collecting data, building data layers and stuff. And that's something which is traditionally done on the front end, using tags on the web and using third-party SDKs on mobile. And that's something which can be moved with a server-to-server architecture. That's a good example of something you can move out of the front end. On our app, we could remove 90% of our marketing partners to the back end. So we have really an improved footprint, less SDK. It's also less crashes and potential problems, version conflicts with the third-party SDK. It's really interesting to have a look if you have to implement some of these logics. And let's stop with the server-side part. Okay. Let's now move on to optimizing the bundles. So we'll see the app bundles techniques and the tree shaking.
Okay, so Android App Bundle allows you to provide specialized, optimized bundles to each kind of Android device instead of a big one. We are lucky, Flutter fully supports Android App Bundle, it's fully compatible, and we tested it on our app, and on average, we managed to get a 48% loss of its weight. So
which is quite impressive in the end. And what about iOS?
For iOS, there's also some app thinning tools, but I invite you to go to the documentation if you're interested.
It has changed because
yes.
Before we had the bitcode options and splicing, but the hardware changes, it evolves. So the techniques to optimize evolve too. Now we still talk about app thinning and stuff. So don't hesitate to have a look at the iOS documentation. It's well documented that you can optimize your bundles on this platform. And about tree shaking, well, app bundles it was more about removing the code for the other types of devices. You download only the device optimized for your device. And tree shaking, it's more about removing unused code from the bundle. So there are many things in our code which can be removed when unused. And we won't go into too much details because last year there was a very good presentation of tree shaking by Alexander here at Flutter Heroes. Don't hesitate to go back to it to learn more. But it's what you have to know. It happens at compile all step in the Flutter build, and we made some experiments and tests, and in particular with the Flutter Google Wallet plugin we've open sourced last year, and really we had good results, good benefits by using tree shaking on that. We also learned a few things. For instance, the location of the Android and Gradle files, which must be correct for tree shaking to work. And the assets are not tree shaked by default. You have to configure that you also want the assets to be tree shaked. And also the conditional imports, which, so I know, so far are available only for the web. So there are a couple of interesting issues opened in the Flutter backlog. It's to be continued, but still tree shaking is really a nice feature in Flutter. You should have a look.
Yes, maybe
And
let's
let's
go
talk about deferred components now.
Yes, yes,
Who
you're right.
knows about deferred components in the
Yes,
audience?
just
please?
curious. How many person? Okay, how many
Oh,
people?
not
Okay,
many
okay,
of
just
you.
few person. Okay, great.
Very few of you.
It's a good time to share this technique with you. Okay, so Deferred Components is based on Android dynamic features. So the main purpose is to load asynchronously or on demand your feature. That means only when users need it. So the good thing is that when you download your app, you don't need to download the feature. So it consists to load asynchronously your app, as I said, and yes, you have no disturbance with it, and it loads seamlessly if network is available. So you will save network bandwidth and you will save phone storage on older device. So of course, you will reduce your memory footprint. And I would add a good thing is that the lazy loading with other platforms is replaced with eager. So it's totally transparent for other platforms.
You mean if you're downloading the app for a platform which is not compatible with deferred components, with Android dynamic features, then it will eagerly load the module, so you see nothing, no problem, and you don't have to code the thing twice for each type of platform.
Yes,
So
you're
that's
right.
really a great feature.
Yes,
And
no trouble with other platforms.
We have an
yes.
example in our application, a really good candidate.
Yes, yes. A good example is how EDFM support on our app. It's a group of features which represents a good candidate to deferred component because it's not used frequently. It's only used when you are in Paris. And yes, Alexi will show you some code samples about the deferred component on the next slide.
How do we configure that?
So first you import the package as deferred. Then whenever you need to use the SDK, you need to call load library. Warning, if you forget to call load library, it will load eagerly. Then at this point, it might fail during the build.
It often fails the first time, I guess.
Always fails in the first time.
But the compiler tells you why.
You can
That's
do
the good
some
part.
plumbing. You just
your
have
best
to
friend.
declare in the pub spec, in the Android manifest, in the build.gradle, sorry, and you're good to go.
And once that's done, after the plumbing,
Once that's done, you can observe a magnificent .so file in the archive which was generated. And then when you run your app on runtime, only on release mode, you can read in the logs that the
it's what's called
feature
a split.
was successfully copied, verified, extracted, and installed.
And that's it for deferred components.
Yeah. Well done.
Really quite magical. And until now, the latest techniques we have seen, they are provided, they are offered by our tools, our frameworks, the native operating systems sometimes. Let's now imagine we can do some things ourselves, not only using provided techniques
Yes.
and features. The idea would be to detect things and modify our application ourselves, its behavior, to reduce the footprint, to improve the performance, to improve the user experience. For instance, we could detect that the user is in saving energy mode, or maybe there's a low bandwidth or low battery. We could detect the type of device it is, and maybe we can see that there's not much memory on this device, or small screen, etc. And after this detection, we have to do it ourselves. We could adapt the behavior of our application. So it's a do-it-yourself part. And once we detected some special conditions like that, what could we adjust, optimize in our application, for instance?
Yes, concretely, here you have few things that you can disable or adjust on different threads. So on the one hand, you have the rest thread that you can disable huge animations or useless effects on your screen. And on the other hand, you have the US thread that you can simply add a cache with more time to live and disable some SDKs. And right below, we have an example to share with us, an example in our code that we can just adjust the accuracy concerning the geolocation. So with this kind of code, we are able to adapt our features and then, of course, improve our performance app.
And Alexis, can you tell us about the results we had by doing that?
Yes, of course. We tested it on our onboarding wizard, which had a lot of animations, which we disabled for low-end devices, and we came up with pretty interesting results. For example, we improved the frame per second to 60 frames per second, and we lowered the CPU and memory usage by some percentage.
So we slightly degraded the UI, the animations, but we think we improved the user experience for these users. So it's all about choosing, thinking about it with your team, on your product, and see with your users if what compromise you would want to implement.
Yes, and
but the good news is, it's not so difficult to implement
that. It's not so difficult. Alexander will agree with me. There's no hardcore skills required to do this.
Yeah, really, it's not difficult, but okay. Try to determine if your phone is a low-end device or not. It still needs some effort, right? So we think that a plugin Flutter could help on that. So that's why we are just creating a Flutter plugin, Eco Mode, and it could be determined an eco-friendly mode on your phone. And we think that combining available information on different OS with simple rules, we will be able to adapt our features and then, of course, reduce our footprint.
We just started working on it, but we think it could be a useful plugin for the community to help users, to help developers.
Yes, thank you. Thanks a lot. Thank you.
It reminds me of all the user agent plugins on the web who know the device and tell you, okay, that's this type of device, and we could go further and have rules to say, okay, we can consider this device as a low-end device and make it easier for developers. So don't hesitate to have a look, to contact us, and we would be glad to exchange ideas and work on this. It's really the beginning. There's not much code for the moment. Another thing we wanted to share with you, if you try to implement your own eco-friendly mode, is thinking about the UI. And it comes from the UI designer, his name is Thomas Thibault. We found this talk really inspiring. It's in French, but you'll have the automatic subtitles to help. It's a very interesting reflection about the options and eco-friendly options you could propose to your users and how to present them. It's really interesting, really inspiring. So we wanted to share that with you. You'll find the slides and the links and everything, and don't worry. And we'll end this big section and overview of a kind of catalog of developer techniques, and we'll move on to more rapidly on the testing and monitoring techniques, because that's one thing to optimize your code, but you should also test the results and monitor that over time, verify you're not going backwards. So obviously you have runtime analysis tools. We mentioned GreenSpector, but there are many of them. You get these types of results, charts, and for instance, this scenario ranking with respect to carbon footprint is really useful to us. It's a good way to focus on the most relevant scenario to optimize. You also have static code analysis tools.
Yes. I would like to introduce EcoCode. So what is EcoCode? EcoCode is an open source project initiated in France in 2019, and they work on different environmental rules about our code. So concretely, it's a plugin sonar that scans our package, and they try to calculate some environmental debt with some code smells. And they have Android and iOS rules, but unfortunately, it's not possible for us to use this rule because it's not possible to scan or build Android and iOS package. So they need us, the Flutter community, to build together eco rules, and then we'll be able to use this kind of plugin.
As you said at first, the EcoCode project the community project was about gathering and defining best practices, rules, quite abstract maybe. But then they added and implemented SonarCube plugins to check these rules. So there are different ways we can contribute, and we really think the Flutter community, we could contribute to this project, this community project. That's really interesting, and that could help us checking our code more easily. We also have all about testing, the testing tools. Is there someone from BAM in the audience? Yes, hello.
Yes, Flashlight developed by the very talented people from BAM. With Flashlight, it's the lighthouse for mobile. You can run tests and obtain some data about your app, like the CPU memory usage and the frame per second. You can run multiple suites of tests, and you can
compare versions, compare your application
versions.
after modification.
It combines nicely with your end-to-end test, but also with your CI. So it's also great for debugging, as you can record some videos while running. Yeah.
Obviously, we won't have time for a demo or something, but we found Flashlight really useful, combined with Maestro, for instance, another great tool. And I'm sure the BAM team will be glad to tell you more about Flashlight today.
Yes.
We have other tools to mention about integration testing.
Yes, another way is making your own integration test. So thanks to the custom Flutter driver, you have the possibility to trace user actions. And on the right side of the slide, you have an example of recording results in a JSON file. And we can see that we have many metrics about performance, like FPS, memory usage, and so on. And to finish, you have the possibility to upload this file in a Chrome tool like Perfetto, and with Perfetto, you will analyze and observe your results with a timeline or many charts. So,
unless you prefer to analyze the text file.
yes.
No? You prefer to visualize everything? Okay, do it graphically? Okay. No judgment. And a last tool, testing technique we wanted to mention and show to you is the golden test. So we love Flutter. Obviously, we love golden tests. Everyone uses golden tests. We also leverage golden tests for many things, including accessibility testing. But we wanted to show you this example because it's also a way to verify our app renders correctly on a small device, on an old device with a small screen, more precisely. So compared to the other tools we've just mentioned, it's not about measuring performance, but more the usability for the user on a small screen, verifying the text renders correctly and everything, the layout. So that is to say we have many techniques to test, to think about the optimization in our code, the footprint, the effect on our user on the device. And that's the time to conclude. We covered many topics. It was quite long review of many techniques. I hope some of them you didn't know, and that was the point, to share maybe some things you didn't know. Why we did want to share all these techniques with you. What do we want you to remember at the end of the day? First, there are many ways, many tools, many techniques you can use to optimize your application and to reduce the footprint for the user, for the device, and for the environment in the end.
And remember to test and monitor your app performance over time. There are already great tools available.
Yes, and there are many solutions we all know, and also few of us know. So it's our responsibility to learn them, to use them, and obviously to share them, please.
Sharing them is really important too. That's why we were here today. That was the point of this presentation. Last year we've shared more resources, and we tried to share things on various topics about Flutter that we love with the community. We feel like it's really important. And today we wanted to share with you the techniques we've identified to improve the carbon footprint, but we are sure you also have other solutions, other ideas to contribute. So don't hesitate to share them too. And if you're interested in working with us, maybe we have jobs open. We'll be glad to share with you, to answer questions. Maybe we have a couple of minutes for questions, and we'll have the break too. I'm sure you have solutions and you have ideas and techniques to propose to improve the performance and reduce the footprint. So don't hesitate to ask questions and to share your ideas. Don't hesitate to contact us. And thank you. Thank you a lot.
Yes, thank you. Thank you very much.
Thank you, guys. Thank you.
Okay.